We start with the idea of a function f of x, y, a function of two variables x and y. And for example, let's just suppose that f of xy equals x squared y plus y sine of, and I started to write t, but let's make that into an x. For any value of x and any values of x and y, we can evaluate this function, and we can say that, well, let's let z stand for whatever we get when we evaluate this function of x and y. We can construct a graph in x, y, z space, and for any point in the xy plane, we can evaluate the function. We put the x coordinate and the y coordinate in, and we're going to get a z value, which means that if this is a point, and let's call this point x naught, y naught, then plugging those points in, we get a z value, and the height of this line is going to be f of x naught, y naught. So we have point x naught, y naught, and a point f of x naught, y naught on a graph. Now, let's consider what happens if we change x by a little bit. If we change x by a little bit, then since our x-axis is in this direction, that means we're going to move to another point in the xy plane. So we're going to have a delta x, which is denoted by this little arrow here. We could consider that to be a vector if we want, a multiple of the I vector. But it tells us how far we move in the x direction. We could also think of moving in the y direction, so that we would have a delta y. Now the labeling is getting a little confusing, so let's just kind of isolate that picture over here. So in the xy plane, we have a point. That's going to be x naught, y naught, and we're going to have some delta x here and some delta y here. And we can actually construct a delta x by delta y rectangle in the xy plane. The value of f is going to change when we move along the y direction, or when we move along the x direction, or if we move at some angle to the x-axis or to the y-axis. And we want to analyze that change. Now let's just consider the delta y part here. So here's our graph point, here's our point, and let's go ahead and label this point. This is x naught, y naught, f of x naught, y naught. And this point here will be, well, let's go ahead and let's assume that z increases between whatever point this is and whatever point this is. So that this point is going to be x naught, y naught plus delta y, f of x naught, y naught plus delta y. And the length of this vertical line is our f of x naught, y naught plus delta y. We're also going to have a point above this point here. So let's just say that we come up to, say, here. And what are the coordinates of this point going to be? Well, if this point here is x naught, y naught, and I labeled it over here, I haven't labeled it here just because the labeling is going to get in my way. But when we moved delta x from the x0, y0 point, we ended up at x0 plus delta x. Our y-coordinate hasn't changed, so it's still y, and our function has value f of x0 plus delta x, y. Those are going to be the coordinates of this point. Now, using those coordinates, we can construct a three-dimensional figure. One of whose sides goes in the y direction and apparently goes a little bit higher, one of which goes in the x direction, and don't know if that goes a little higher or a little lower. It actually goes a little lower because the x direction's here, and this is pointing a little below the x direction. We can conjecture that if delta x and delta y aren't too big, that the slope of the graph, that the rate of change of the graph as we move in the y direction isn't going to be too much different between here and here, so that we can draw a side that we assume to be approximately parallel to this side. And similarly, that moving a small distance delta x isn't going to change the way the function behaves too drastically, so that we can complete a picture of a segment or a section of this graph, f of xy. It's increasing as we move in the y direction. It's apparently decreasing as we move in the x direction. This picture corresponds somewhat to this three-dimensional shape that we're familiar with from the introduction. Set this on a plane. Let this be your x0, y0 point. You got a delta y, or let this be your x0, y0 point right here at this corner. And you're going to have an increase as you move in the y direction, a decrease as you move in the x direction. And of course, this could be oriented in any way and interpreted in a variety of different ways.